Okay, up to now we've been looking at data that basically has one variable, and when you have one variable you make things like box plots and histograms and normal probability plots, those kind of things. Now we're going to move on into situations where you have two variables, which hopefully is something that's not totally unfamiliar to you, other than the language changes a little bit when you go into statistics. Okay. One of the things you need to realize is that when you're looking at two variables, you're trying to show a relationship between those. And we use a different language than you do in math class, which you'll use x and y axis, or in science class where you use independent and dependent variables. In statistics class, we use explanatory and response variables. Basically, the response variables measures the outcome of the study, better known as the y-axis in math or the dependent variable in science. And the explanatory variable tries to influence the response variable, and we call that the x-axis, or in science class, the independent variable. In most situations, we are trying to show that there's a relationship between those two. However, just because we see a relationship doesn't mean that there's a cause and effect. Okay? It does require a little bit deeper analysis to show that is true. So make sure you record the definitions here in your notes, in your composition notebook, or the provided worksheet that goes along with this video. When you get into one variable statistics, as we've been doing, there are many ways to display the graphs. As I mentioned earlier, box plots to dot plots to histograms. However, when you get into two variables, there really is only one way that they describe that, and that's via a scatterplot, which just has a bunch of dots scattered around, and you're looking for a pattern, usually within that scatterplot. But again, this definition needs to be recorded in your notes, and it shows a relationship. A scatterplot shows a relationship between two quantitative variables. We only use scatterplots with quantitative data. We always put the x-axis and the y-axis, which is called the explanatory variable, and the response variable. As far as to make a scatterplot, you need to make sure you have the right variable on the right axis. You need to label and scale your axis appropriately. Putting labels and units are very important to making sure you can interpret the graph correctly. And scaling your axis means that as you move across, you use equal increments. In other words, if you're going across by 5s, you do that all the way going across 5, 10, 15, 20. The worst thing you can do is to scale it so that it's not scaled consistently. Go 5 and then 9 and then 12 and then 17 or something like that where it's not consistent. You also need to scale the y-axis. Please note that the x and y-axis do not have to be scaled in the same way. If you go across by 5s on the x-axis, the y-axis you can go up by 20s, depending on the situation there. Okay? The next thing is then to plot, usually using dots, plot the individual data points that you have gathered in your experiment or observation. So here's an example of that situation, trying to show a relationship between body weight and pack weight. So one of the first things you need to do is decide what's your explanatory variable, what's your response variable, which one is influencing which one. Well, the idea here is that if you're looking at body weight and pack weight, your body weight is going to influence your pack weight. Somebody who is heavier, hopefully is a little bit stronger, can probably put a pack on their back that weighs a little bit more, whereas someone who is very petite or very small isn't going to put a heavy backpack on. So the idea is the body weight would be your explanatory variable, and hence would be down in on the x-axis. If you notice here, the body weight is on the x-axis, and the pack weight would be on your y-axis. That would be your response variable. And we've collected some data from several different hikers, and we've plotted each individual point. So if you notice here, 120, 26 is this point right here. Because I scaled the x-axis by 10s. Notice it didn't have to start at 0. We do not have to do that. I know in science class a lot of times you want a graph that starts at 0, but in statistics it doesn't have to be that way. And if you notice, the y-axis is starting at 20 and going up by 2s. So again, it's scaled consistently going up, but not necessarily the same that the x-axis was scaled in. Because if you look here, the body weight is between numbers like from about 100 up to about 190. You see a high of 187, where the backpack weight is considerably smaller numbers. So again, depending on your data, that's how you make a decision about how you scale each of the axes. Once you create a scatter plot, what you're looking for is patterns within that scatter plot. And kind of following the same ideas that we did in the previous chapters, we're looking for overall patterns, for striking departures, unusual features. We're looking for shape and more strength and spread. Okay? There are three big things that you want to describe anytime you describe any kind of pattern in a scatter plot. And those three things are direction. Is it going up or is it going down? Which we'll say is it positive or negative. Form. Basically it's linear or it's nonlinear. In this course we will briefly look at scatter plots that are curves, but we will concentrate mostly on linear relationships. So basically you want to be able to look at that and say, yeah, it's linear, or no, it's not. And the strength, we'll get more detail on that, but usually that's anywhere from weak to moderate to strong, or some combination. Sometimes you say moderately strong, or something along those lines. And we also want to mention any outliers, any unusual features, that's some dots that don't seem to match up with the rest of the data that we've collected. Okay, so once again, and again include these notes, the three things that you wanted to describe anytime you're describing a scatter plot is direction, form, and strength. Sort of like cussing and BS when you're doing one variable data. Direction, form, and strength is what you're going to describe every time you see a scatter plot with two variable data. So if we try to make a scatter plot of the backpack data versus the body weight data, we can see that there's definitely a positive relationship. The line is going up. It's moderately strong. Your line kind of closely follows a line. It's not perfect, but it certainly you can definitely see a relationship there, and definitely looks linear. The relationship does look linear, but we do want to notice here that there's one outlier. That person who weighed 187 pounds only had a backpack of 29, and it doesn't seem to follow the rest of the pattern. So we want to identify that one outlier. Okay, but you can see here that this is a good sentence that describes it, that this is a moderately strong, i.e. strength, positive, that's the direction, linear relationship, which is the form, between body weight and back weight. So in other words, people who weigh heavier tend to carry heavier backpacks, and likewise people who weigh lighter also carry lighter backpacks. Okay, so a positive association basically is when you see a graph that's moving up. You know, as you move across the x-axis, the y values are getting bigger and bigger. A negative association would be in reverse. As you move across the x-axis, the y values are getting smaller and smaller. So here's an example of a scatter plot, a little bit different situation. I'm trying to relate the percent of people who take SAT and their average math score, or their mean math score. And if we're looking at the strength, direction, and form here, you would notice here that this is not linear. Because if I were to try to kind of draw something that goes to the middle of this, you can see I'm getting more of a curve. However, it's a curve that is going down, so there is a negative direction to that. And it's not a bad curve. It's certainly, I can see a pattern there. It's not perfect by any means. It's got a lot of points that are far away from it, but it's not bad. So if I were to describe this from a strength, direction, and form standpoint, you can see here the strength is moderately strong. The direction is negative because the curve is going down, and the form is that it is a curve relationship, although as I mentioned in this class, we might even say nonlinear, which is another appropriate description here. And it's trying to show, so the sentence here would be there's a moderately strong negative curve relationship, or negative nonlinear relationship between the percent of students in the state who take the SAT and the mean SAT math scores. Okay, and you might also notice here that there are two clusters here. If you notice, there's a bunch of data here that's really clustered together, and there's another data here that's clustered together, and we do also have some possible outliers here that don't seem to follow the rest of the pattern. So we want to mention those, any kind of patterns that we see there. Okay, but these are the three big things that you need to include in your descriptions.